In this video, we will go over focus and directrix of a parabola. And so just visually, if we look at this, we know that x does not equal y. Y is clearly bigger than x. Now this is because I did not choose the correct focus. Now it's very important to note that if this is A, this distance right here is A, and this distance right here is also A. This doesn't mean that that's the correct focus and that's the correct directrix, because the focus is going to be a very specific point and the directrix is a specific line. Let me go back a little bit. So, by definition, a parabola is a set of all points in a plane that will be equidistant from the focus, from the fixed point and the directrix, a fixed line. So this parabola right here, this red parabola right here, it's very important. By definition, the true focus, this point to the parabola and then down to the directrix, will always be equidistant. This is by definition of a parabola. Now in this video, we will go over how we can determine the focus and the directrix. So now here's another example. Now just visually, if you look at it, x and y is equal, or much closer than the previous slide. So the true focus will result where we can take the focus and go to any point of the parabola here, and then you can go down and the distance will be the same. So x and y will be the same. Another example, I could go from here to this point and then go down, and that distance will be the same, x and y. And so let's apply the definition of a parabola. And so here we're not saying what a is equal to. So we know the axis of symmetry is 0, and we will apply the distance formula. Because by definition of a parabola, this L and this L will equal the same. They're equidistant. So I can say the square root. So with PS, the square root. So I have x minus 0 squared plus y minus a squared is equal to. So this point right here is x comma negative a. And here is x comma y. And so this distance here will be y plus a. Because I'm starting at y and I go all the way down to negative a. And so that distance will be y plus a. Another way to think about it is from here to here is y, and from here to here is a. And that's why it's y plus a. And so let's do some math. So I'm going to square this side, and if I do that, I need to square this side. And so I would get x squared plus y minus a squared is equal to this piece squared. I'm simply canceling the square root by squaring this side and squaring this side. And so I would get x squared plus, if I expand this piece, so y times y is y squared, y times negative a is negative ay, plus negative ay would be negative 2ay, and then negative a times negative a is positive a squared. Now same idea, so y squared plus 2ay plus a squared. And so if I move this y squared over to the left, this would cancel. This piece and this piece would cancel. Likewise, the a and a would cancel. And so I would get x squared minus 2ay is equal to 2ay. So I can move it over, so I could get x squared is equal to 4ay, or I could rearrange and say y is equal to 1 divided by 4a times x squared. And so for example, let's say a problem says x squared is equal to 20y. Then we would know that a is equal to 5. And so the focus would be 0, 5, and then the directrix would be y is equal to negative 5. Now here are some general formulas, and I will explain why this and this are equivalent and this are equivalent. And so here I'm showing the formula for vertical axis of symmetry and horizontal axis of symmetry. And I will show why this and this is equivalent and this is equivalent. So let's say we have y is equal to a parentheses x minus h close parentheses squared plus k. So the vertex would be h comma k, and then the focus would be h comma k plus 1 divided by 4a, and then the directrix, you can kind of think like this distance is 1 divided by 4a, and then this distance is also 1 divided by 4a, but it's going down. And so that's why it's negative 1 divided by 4a. So that's the focus, and that's the directrix. The directrix is a line, and a focus is a point. And here, horizontal axis of symmetry. So same idea. So here, I am saying x is equal to. So that's why the vertex is h comma k, and then the focus would be h plus 1 divided by 4a, comma k, and then the directrix would be y is equal to h minus 1 divided by 4a. And now, depending on your teacher or, maybe an exam, you'll also see these forms too. And so I'll show why this and this is equal. So here we have 4p, and I will say that p is equal to 1 divided by 4a. And so first, I'm going to show why the vertical axis of symmetry for both cases is equivalent. So I'm going to start off with this form, the one we just went over. And I will rearrange. So I can say that y minus k is equal to a parentheses x minus h squared. Divide by a, divide by a. So y minus k divided by a is equal to parentheses x minus h squared. And I'm saying that 1 divided by 4a is equal to p. So 1 is equal to 4a times p, and then so a is equal to 1 divided by 4p. So I'm going to swap a with 1 divided by 4p, and I would get this. So we are going to rearrange. So this right here is y minus k. You could also say y minus k divided by 1. This whole piece divided by 1 divided by 4p. 1 divided by 4p. And so this would equal y minus k divided by 1 times 4p divided by 1. And so we would get 4p parentheses y minus k. And so we can say that this piece right here, 4p parentheses y minus k, is equal to x minus h squared. And then you can rearrange and say parentheses x minus h close parentheses squared is equal to this piece, 4p parentheses y minus k. And so they are equivalent. I suppose one thing you could ask and say, why is 1 divided by 4a equal p? Let's just think about this. I'm going to swap p with 1 divided by 4a. And so I would get 1 divided by a parentheses y minus k. I could then move the a over, and I would get a times parentheses x minus h close parentheses squared is equal to y minus k. Add k, and they're also equivalent that way. And here I show how the horizontal axis of symmetry, that they're equivalent, this form and this form. And so it's the same idea. So if you want to pause the video and look at it, I would recommend doing that. And so now let's do an actual problem. So we want to determine the focus for this parabola right here. And so I would recommend, let's label the parts first. So A would correspond to 1/4, H would correspond to 3, and K would correspond to 2. And so the vertex would be 3, 2. And then the focus would be 3, 2 plus 1 divided by 4a. And a is 1/4. So we would get 3, 2 plus 1. So the focus is 3, 3. And now let's actually visualize it. So the focus is 3, 3. The vertex is 3, 2. And then the directrix is a line, and it's going to be 1 less. So this is 2, this is 3, this is going to be 1. So the line is going to be y is equal to 1. And then this right here is the axis of symmetry, the vertical axis of symmetry. Now we just expanded it. So from this focus to any point of the parabola here, then I go straight down to the directrix. So this length of y and this length of y is equal. And just visually looking at it, you can kind of tell that it's equal or very, very close, depending on how accurately I drew my line. Likewise, from this point to this point of the parabola, then straight down, they're equal. So this length is x, this length is also x. And here I'm actually going ahead and proving that they are equal. So this point right here is 0, 17, 4. Now, how did I get that? So if I plug in a 0 here, the y value would be 17, 4. So this vertex is 3, 3, and this point is 0, 17 divided by 4. So let's use the distance formula. So we do 3 minus 0 squared plus 3 minus 17 divided by 4 squared. And then we get the value of x is 3.25. This distance is 3.25. Likewise, let's do the distance for y. So it's just vertical. So here is 1. Here is 17 divided by 4. 17 divided by 4 minus 1 is 3.25. And so we just proved that this distance and this distance is equal. Now here I'm just trying to emphasize this again, that you can't just say any point is your focus, even if this and this is the same length. Because if I do that from here to here, let's say it's A, from here to here is B. Obviously B is bigger than A. This is because the red line is not the true focus and the black line is not the directrix. despite x and y being equal. Now we're going to do one more problem. This problem will have horizontal axis of symmetry. And so I'm going to use this formula here. So we have x is equal to 1 divided by 4 parentheses y minus 3 squared plus 2. So let's label our parts. A is equal to 1 divided by 4, h is equal to 2, and k is equal to 3, simply matching our points. And so the vertex would be 2, 3, and then the focus would be h plus 1 divided by 4a, k. So our h is 2 plus 1 divided by 4 times a. A is 1/4. So 1 divided by 4 times parentheses 1/4, k. K is 3. So 1 divided by 4 times parentheses 1/4. So this becomes 1. So 2 plus 1 is 3. So we have 3, 3 as our focus. And the directrix, we use this formula here. So we get 2 minus 1 divided by parentheses 4 times parentheses 1/4. So we get 2 minus 1. So the vertex is 2, 3. The focus is 3, 3. And then the directrix is x is equal to 1. And I'm showing again, from this point to this point of the parabola is length of x. And then from this point to the directrix is also length of x. And that's pretty much it for this video.